This video was made for a friend, but other people might find it informative, so I'm leaving it public on YouTube. This video will cover recursive functions and how to use them to make the dragon curve fractal, which is pictured here. A function is a piece of code that you primarily use to change the value of something you have stored, or to tell you that value. For instance, you can have a function that you use to call the value of something you put in a different place in your program. You might have a function that increments a value, like if you want a character in a video game to move. You might call a function that increases its y value on the press of an up arrow. There are different types of values or variables to use, such as integers. So in this example we have here, this is an integer where the y level is stored as a number, and the higher the y level, the higher up this bird is in between these frames. They can also be strings. So strings are just a compilation of letters and symbols and whatever characters you have, or lists. A list is a type of variable that can store more variables in it. We'll talk about those in just one second. But yeah, here what you see is you might call the function bird y, and you tell it to increment its value by 200. So in between frames, the y level increases by 200, and the bird character moves up 200 pixels, presumably. A list is a variable that holds a set of values, and you can find the value of that variable by calling that list at a specific point. So in this example, we have a list that is a deck. It's an actual deck of cards. It's a list of all of the cards in there. And what you can do is you can shuffle that deck, so you can put all the cards in a different spot. And then if you were to make some game based off of that, you could actually call the deck and call maybe the first two cards in that deck if you wanted to deal out, a poker hand or something like that. You can also add things to the end of that list. A string is a line of characters like we were talking about a little bit ago, or maybe even a single character. We're going to be using single length characters for this, but we're just going to be calling them strings. And we're going to be giving it an R when we're telling the program to turn right, and an L when we tell the program to turn left. Recursion is when a function calls itself a certain number of times to help solve a problem. And you would probably use recursion intuitively to solve some problems. For instance, maybe we want to sum all numbers from 1 to n, or from 1 to 100. What most people would do would be to start with solving for the very simplest of these cases, to solve for summing 1 through 1, and then add 2 to get the next answer, then 3, then 4, then so on until they're finished. What you can think of this as is solving a very simple problem to get to the next one, to get to the next one, to get to the next one, and that's what we have here. Let's look at another example of recursion, and this time we're making another fractal, but a simpler one that just zigzags. So what you would do is, on the first iteration, your list of turns would be just nothing. There's no turns, it just goes in a straight line. Second iteration, it turns right once. Third iteration would turn right, then left, then right, then left, then right, then left, etc., 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 and so on. So what you would do is you would solve for the first iteration, which would be just nothing, and you could kind of know that ahead of time. In the second iteration, you would just add R, and then from the third iteration and onwards, if the last turn is an R, you would add an L next, so it would turn left, and vice versa. Now, if you look at the list of turns associated with each of these iterations, you can actually predict what the next iteration will be from the one before it. So what you would do is you would take that whole list of turns and just keep it as normal. Then you would add an R because you're going to turn right next, and then you're essentially just going backwards through the fractal. So you'd have to change every right to a left and then reverse it. And that's what you see happening. So how to go from the first to the second, you take the whole list, which is just R, then you add an R, and you go backwards, changing every R to an L. This one is pretty simple. You do the same with the third iteration and with the fourth iteration, and it just gets bigger and bigger and bigger. This is the part of the code that programs all the turns, that can generate all the turns for Python.